A motivational intro should not be needed, but if you're already thinking of leaving, what are you thinking? Dark matter and dark energy disappear with new physics. General relativity has geometrized reality into two objects: energy and space-time. Energy shapes space-time and space-time transports energy. They influence each other. Taking a look at the foundational equation, we see on the left side of the equal sign a tensor to describe the geometry, the shape of space-time, and on the right side the tensor for the geometry of energy in space-time. The source of change in the geometry of space-time is energy. Discovering gravitational waves through space-time as a result of moving energy has shown that space-time can be quite dynamic. Its cause is moving energy. Modern physics talks of three types of energy. Two are conjectured: dark energy and dark matter. One is our familiar normal matter. Our standard model of physics describes the particles that make up normal matter. We are guessing about the nature of dark matter and dark energy. That is why they are called dark. For dark matter, physicists are looking for new particles probably missing from the standard model. Dark energy is a conjectured source of energy that makes the universe expansion accelerate. We think the universe's expansion accelerates because we interpret redshifts of stars in a particular way. Stars and galaxies. New physics starts with the conjecture that there is no division in nature. Nature is one dynamic object instead of two objects, where nature is divided into space-time and energy. This object is called space-time with capital letters S and T. I shall call it space-time capital to distinguish from Einstein's space-time. Space-time capital is dynamic because of its properties, its shape, and its elasticity. The difference between space-time and space-time capital is the explicit function of elasticity. This is in fact makes space-time capital more dynamical than space-time. Not in principle, but in practice. Dark matter can be found in the foundational equation of general relativity on the left side of the equation, so to speak. But we are only looking on the right side. Space-time capital has a new solution for what we think are dark energy and dark matter. Dark matter is just moving waves, like gravitational waves, but with much larger wavelength and moving slower than light. Moving slower than light because of the complexity of the waveform. So the dark matter that physicists are talking about nowadays doesn't exist. The moving waves can exist in Einstein's spacetime, but the theory doesn't give a reason for their being. The measurement results so far seem much in favor of this new model. Dark energy is different. It doesn't exist for another reason if space-time capital is real. In fact, dark energy will probably be a nonsense concept from the wrong interpretation of measurement results. Physicists nowadays have to make up stories to save the law of conservation of energy. That should be an indicator. If space-time capital is real, and we can find the machinery for fermions, the redshift measurements can be interpreted with 4 different possible reasons for redshift. In current physics, there is only one available reason: the movement of galaxies and stars, which forces us into the concept of dark energy. The four reasons are the variable size of the fermion carrier ball, movement of galaxies and stars, possibly variable speed of light, and distance measurements are more dynamical than assumed. These influences are explained in the book New Perspective. A link is in the description below. With these four reasons to interpret the measurement data, it seems unlikely to me that we live in a universe with accelerated expansion. Dark energy is premature speculation. We shouldn't speculate on it before we have proper machinery underlying our symmetries and other descriptions of nature.